Getting a robot to consistently see and track AprilTags is the difference between a precise autonomous routine and one that completely misses the mark. We want to be in the AprilTags connection. And honestly, without a little bit of tuning, it's already that good. In this video, I'm going to give you my process for calibrating the Limelight 3A to get reliable and consistent AprilTag returns. It's the foundation for accurate robotic localization, whether you're on an FTC team or you're building your own custom robot. As a robotics educator for over 10 years and a coach of national FTC championship teams, I know that a solid calibration is non-negotiable for high-level robot performance. Taking your time to calibrate properly will save you so much of a headache in the future. Garbage in, garbage out, as they say. I'm Brogan Pratt, and I'm going to run you through a quick overview of what AprilTags are and why they're so useful in robotics. I'll tell you the difference between what a 2D and a 3D data returns are, and I'll also show you how you can create a point of interest relative to the AprilTag so you know exactly where the scoring implements are compared to your robot. Then we'll go through step by step through the Limelight interface and get your camera and pipeline settings dialed in perfectly. So before we get into how to actually set up the Limelight for AprilTags, it would help to have a little bit of an introduction as to what an AprilTag actually is. You've probably seen these already before. This is a QR code or a quick reference code, and it allows a camera to be able to scan this, and it can bring you some sort of data or some sort of information related to this code. Problem with using QR codes in robotics is that they're quite high resolution. There's a lot of detail packed into this. It could be really challenging to have such a high resolution picture pick up quickly and respond quickly. So instead in robotics, we typically use something called an AprilTag. And an AprilTag is kind of like a QR code, except there's only so many known tags that can exist. So for instance, these are 6 different families of tags, and each family of tags has a specific resolution that it has inside of it, how many pixels are going to be inside of it, what it's generally going to look like. And then, for instance, the tag 36H11 family has, I think it's several 100,000 tags that exist, but unlike a QR code, every single tag in every single family group would be, this is tag 0, this is tag 1, this is tag 2. And regardless of where you go in the world, if you grab this family, that exact setup will always be indicative of tag 0 or tag 1 or so on and so forth. So what exactly is the benefit of using an AprilTag? Well, the cool thing about using an AprilTag is that it allows your robot to know where it is in physical space. So you can think of it kind of like the robot can look at this tag, and provided it's got a map uploaded of where this tag should be, or you have some sort of information that tells it where this, think of it kind of like a park map. Tag 12 might be the gorillas. Tag 13 might be the elephants. And if it says tag 13 and the robot sees tag 13, then it knows it must be near the elephants. But only does it know that it must be near the elephants, it can tell how far away am I from the code, how far to the left or to the right am I from the code, and how far up and down am I from the code. And not only that, am I looking up at the code, am I looking down, and then am I also pitched, yawed, and what's my heading like, or am I rolled across that as well? So you can know exactly where your robot is in 3D space by looking at these predefined tags, provided that there's a map uploaded that the robot knows what it should look like inside of that space. So basically, an AprilTag answers 2 questions. What am I looking at, and how is it in relative space to me? So the cool thing about AprilTags is they work even if they're slightly blurry, if they're at an angle compared to your robot. In fact, they actually work better if they're at an angle compared if they're directly face on to your robot. And they're really fast to process. You don't need a super high resolution to get these things up and running. So let's get started with the Limelight 3A and connecting this. Now, of course, the easy way to get this thing connected, all you need is your USB-C connection that's already connected with USB-A to your computer. Go ahead and plug that in, and we're going to wait for this thing to boot up. In terms of my setup today, I've just got my Limelight set up on a tripod, looking down at some pieces of paper. So now that our Limelight is booted up, we can go to http://limelight.local:5801. That should bring us to the local web section of our Limelight. Now, I'm currently running 25.1 as my software. If you're running something older, you might see something about network table or ignore network table switching, something along those lines. So We are going to allow user pipeline switching, and I'm going to go ahead and select the 8th pipeline in here because this is just for a little bit of experimenting. If you are going to set this as a pure pipeline, gear will name, but for now, because it's just a test, I like to use the lower pipelines just so we can throw it around. Right now, it's in color or retroflective. This is not the mode that we want to be in. Actually, I'm going to zoom in a bit so you guys can actually see. We want to be in the AprilTags connection. And honestly, without a little bit of tuning, it's already that good. It already recognizes that this is tag ID number 11. Let me swap out a paper here. Tag ID number 12. Even without any tuning, it's a really solid camera. And you know what? It can even check out 2 tags. There you go. It knows which one's 11. It knows which one is 12. And it knows where it is in physical space. If we were to rock our camera around here, you can see it moving around. But of course, things always work better with a little bit of tuning. So let's do some tuning. One thing to note, make sure your AprilTags are flat. If they are up and curved, it will not be as accurate, as you can see. So it has to be flat. Of course, our source image is our camera. Now for resolution, you want to choose the highest resolution that you can here for the most part that still keeps a decent frame rate. The reason I say that on the frame rate is that in FTC, it tends to be a shorter field, or if you're going to use this for FTC, it tends to be a shorter field. So you want to have a slightly higher resolution because it will block out some motion blur. So I have found that 1280 by 960 works pretty well, but we just have to keep a look at that frame rate. Or honestly, 960 by 720 also works really well. You want to try to get at least 60 frames per second if you can. Of course, the human eye can't see anything above 60 frames per second. So, you know, your 140 hertz is not going to matter anyways. I hope you get that is a joke. Your stream orientation, of course, is your ability to flip your camera upside down, depending on how you have this mounted to your robot. Now, the black offset gain for AprilTags, the Limelight documentation suggests 0. And the sensor gain, it suggests a sensor gain of 15. So I wouldn't play with those numbers too much because this is what it literally says in the documentation. Flicker correction, in Europe here, I run in a 50 hertz system, so I'm going to run on that. If you're in North America, you should run in a 60 hertz system. Red balance and blue balance, I wouldn't mess around with those at all. You want to try to reduce your exposure as much as you can until you still get valid tracking. Now, don't fly too close to the sun here. You'll notice that as I start to peak this exposure down, I'm going to start getting a little bit too close to the sun at a certain point. There we go. You can start to see that 11 is starting to jump in and out. So I like to take whatever that value of that jumping point was and then add, 15 to 20 of it just to allow for different lighting conditions. And you really want to make sure you're moving while you're doing this exposure test or moving the Limelight around so that you can ensure that you're still working in different lighting conditions because different lights throughout the field are going to change things. So I'm going to go ahead and move this back to just one AprilTag for now so we don't start confusing our systems. Now I'm going to go ahead and go to my configuration. Inside configuration, the family we have to use, if you're using for FTC robotics, it would be AprilTag Classic 36H11, and there's 587 tags that are recognized inside of this. The engine does not matter, it's still Michigan. The University of Michigan was actually the university that developed the concept of an AprilTag, which is cool. The marker size has to be the correct size for your AprilTags. Again, if you're using FTC robotics, 101.6 is the correct size. Detector downscaling. For FTC or competitive robotics purposes, the higher you put this, the higher the frame rate you're going to get, but the less range you're going to get. Now, the Limelight itself is designed for capturing AprilTags, 9, 10 meters away, would it be? So you may get some reduced range, but if you're using this in competitive robotics, at least in the FTC, where your fields are about 3 meters squared, you can go ahead and bump this detector scale up and watch what happens to the frame rate when we move that. So frame rate is on average about 52, 53. When I bring up to 4, it brings our frame rate to above 60, which is great. Now, quality threshold is a little bit of a slider here so you can keep track of false positives. The lower it is, the more likely you are to catch false positives. The higher it is, the less likely you are to catch false positives. This is going to take a bit of tuning on your part, and for the most part, in my experience, 2 is pretty good. Depends on how reflective your field is, depending on how bright your field is, or how reflective the robots are. So you may want to test this if there's a lot of aluminum out on that field. You might be getting some false reflections. So just do a little bit of testing on your own part in your own timing. ID filters allows you to filter things out. And I'm going to go ahead and show 2 of these on the screen here. Right now, you can see that I've got tag number 11 and tag number 12. What you can do, and I highly suggest you do for each pipeline, is you make a pipeline to detect 1 tag only. And this is from the documentation as well. So if I put in an ID filter of 11, you'll notice that 12 gets ignored. And it's only going to be looking for tag 11 inside of this pipeline so that it knows that this is the tag that it's looking for. You can also use a comma to include multiple tags if you want to include multiple tags. But as per the documentation, I highly suggest that you only select 1 tag per pipeline and then swap your pipeline in code as time goes by. So I'm going to be using an ID filter of 12 for this one, so that if I were to even swap this out for 11, you'll notice that down in the bottom right-hand corner here in our TX results, in our TA, it actually completely disappears until I show the right one. But if I put in both, it's going to depend on its filter for which one is closest. And right now you'll notice it's focusing on 12 because it has that little green dot. But as we move the 11 closer, it's now focusing on 11 as its green dot. So you can end up getting radically different TX or target X and target Y and target area values. So I highly suggest that you only focus on 1 per pipeline. And in fact, while we're here, we'll give this one a pipeline name. Might give this one AprilTag 11. Give it a save. Now the sort mode, you can have the largest, the smallest, the highest, the lowest, rightmost, centmost, closest. If we have multiple here, I'm just going to go ahead and put multiple here. We can see which one is closest to that crosshairs. We can choose the lowest. Now you notice this focusing on 12. If we choose the highest, now it focuses on 11. So for the most part, you probably won't need that. And I just keep this at the default for whatever the largest is because we're only going to select 1. But if you were going to have multiple targets, again, you can choose dual targets if you wanted to. If you have dual targets, you're going to make sure you put in your ID filter. And it's going to choose the midpoint between the 2 as whatever your target return value is. Real quick, if you're finding value in this content and you and your team is getting something from this, it would really help out the channel if you can give this a like and a subscribe. It allows me to reach more robotics enthusiasts like you. But I'm going to go back to 11. I'm going to set this back to single target for now. Down on the advanced section is where you want to do full 3D targeting. Now, for AprilTags, you've got 2 options for targeting. You can do a 2D targeting or you can do a 3D targeting. For 2D, that might be good enough if you just want to know where you are in your X and Y plane compared to it, but it does not allow you to get full field localization or full 3D localization. So if you're going to do 2D, 640 by 480 is more than good enough. If you're going to do 3D, you should have the highest resolution possible. So we're going to go ahead and turn on full 3D targeting, and you notice something different just showed up to our tags. Rather than just seeing the tag themselves, now we have our tag in 3D space. We can actually see how we relate to this object in 3D. So the gyro latency adjustment, you can bring this up a little bit if you find that if your gyro is not quite interacting quick enough for what it is that you need, or if it's a little bit slower on your control hub, perhaps you have slower cycle times. I like to keep this at 0 personally. Down here on this X crop and this Y crop, it allows you to bring in points of interest so that you don't have to be processing as much of the image. And typically, as you bring this in, you can raise your framing up a little bit. So you have to play with this, and it depends on what your robot can see. Maybe you've got a pillar on the right-hand side that you just want to make sure that you take off. It's up to you how much you do. You can probably knock off about 10% from each corner, give yourself a little bit of performance boost, but reality is, testing is really to know whether you have the correct sections and the amount of cutoff that you need. Now we'll talk about this 3D point of interest offset a little bit because I want to talk about this MegaTag field space localization setup. So the MegaTag is the software, or rather the formulas that Limelight uses to know where your robot is in space compared to a AprilTag. This is specific to FRC and FTC, as far as I'm aware. The field map file, depending on what you're using, for a Limelight 3A, it already has an FTC field put in, but you are welcome to upload your own custom field maps. So you can put in your own field for this. Snap a robot to the floor. I like to click this on yes. And let's go ahead and actually set this up so we can have a target post and field camera. And I'm going to click hide the info for now. Now, you can use the W, A, S, and D, and Q brings you down, E brings you up, and then you can use the mouse click to change your view. So we can see here that this yellow space is actually our robot relating to QR code 11. So we can actually see our robot in space. And as we move the Limelight around, left and right and forward and backwards, we can actually see that we move forward and back. Now there's two robots in this space. There's a green robot and a yellow robot. MegaTag 2 requires you to be able to input your robot's yaw in your code. And I'm still waiting on Limelight's response for the MegaTag 2 in that whether it's used specifically for FRC or FTC. In FTC, at this point of recording, I would turn it off and only focus on MegaTag 1 because MegaTag 2 seems to always put my robot directly to the left of the AprilTag, which is kind of odd. So for example, it's not just directly behind. Watch what happens when I switch over to AprilTag 12. Oh, we have that currently turned off. So I'm going to turn that ID filter off. You notice that again, MegaTag 2 seems to be giving me strange results, not what I would expect, because right now my robot is head on, but it seems to be off. So I actually turned the MegaTag 2 tag off. So let's talk about what this field space localization setup is. If you are using the Limelight, you have to put the Limelight into a CAD model of your robot. Well, not have to, but I strongly recommend it because it allows you to actually set up your offset. When we're looking at this space, the Limelight assumes that you are in the direct center of your robot. So right now, it is assumed that it is in the direct center of whatever your robot space is. Now, I know this shows up in an FRC robot, but in FTC, it doesn't really matter. This is just an example. So you can use these offsets here to say where it is on your robot. So let's say that our robot is actually to the right of our robot a little bit. And this is in meters. Okay? So let's say that our Limelight is actually 10 centimeters to the right. So I'm going to put 10 centimeters to the right. You notice that our section just changed. Let's say that your Limelight is also near the very front of your robot, but it's almost at the very front. So let's say, we have 0.2 centimeters to the front of our robot. And then up, rather than being on the very base plane, it's again another 0.2. So we can actually see the Limelight itself has actually moved its space on our robot. We can see that. Maybe let's put it up to 0.4. Oh, no, 0.4. So we can actually see this quite a bit higher. And now we can see exactly where this Limelight is in space relative to our robot, which is pretty cool. You can also go ahead and set your yaw and your pitch of your robot. And the reason I say using your CAD software on this is that you can actually calculate these things directly from the origin point in the middle of your robot. So let's go ahead and for me, I've got a little bit of a pitch angle. I would hope you would not set this up to have a roll that would be a tilt this way. So for instance, if I were to look at my camera here, this would be a roll, this would be a pitch, and this would be a yaw or your heading. So in my case, my yaw is the exact same as my robot because I don't have it set up on an angle, but I do have a pitch angle. So I might say 10 degrees. Actually, this one's probably negative 30 degrees. So I've got it pitched down. And I'm going to do negative 15 because that's about what my tripod is actually set at. So we can see that according to my current setup, I'm basically right beside the AprilTag. And as I move backwards, we can see our space sets up a little bit more. So you need to have these things set up perfectly related on your CAD software in order to have these give you accurate and reliable settings. But as I actually start moving around, we can actually see that our Limelight moves and is quite resilient to be able to track this AprilTag, which is really, really cool. There are other views you can use inside the visualizer. Of course, there's target pose in robot setup, which means that you are currently in the robot's field of perspective and you are looking at what the final point is. So in this case, we are the robot and we're looking at where the AprilTag is in respect to us. The robot pose in target means that we are viewing from the target and we're looking at what the robot's pose is. The robot pose in field, let's go ahead and hide that info, is the one that I use the most frequently, in that the robot is going to move around and we are in a field-centric view. The target pose in camera is, again, keeping where the camera's view is, looking at that, similar to the robot. The camera pose in target is looking at where the camera is in relation to that QR code. The top-down target is just an XY coordinate. This would be more useful if you're using 2D tracking, just where this thing is in space. And then a top-down target, but again, where the camera is relative to that point. So it depends on whether you're going to be using 2D or 3D for that kind of localization. So I'm going to go ahead and go back to the robot pose in field, and I'll go ahead and hide this info. Again, I like to turn off the MegaTag 2, or at least for FTC, because it gives me some unreliable data. Now let's go back up to this 3D point of interest offset. What this is it allows you to put in something in the field that has a known distance away from an AprilTag. So let's say, for example, you have a bucket that is always placed 10 centimeters to the left of your QR code and 5 centimeters up of the QR code, and you want to target this. This data down here that the Limelight's going to return is your target X compared to where your robot is compared to the AprilTag, the target Y, the target area, which is the percentage of the screen that is pacing up, and TL stands for target latency in milliseconds, so for how long it takes for you to actually get that information back. So right now it's targeting that exact center related to our crosshair. But let's say that you're setting this up, that you want to use the AprilTag to be able to know where the bucket is in space. And you want to be able to place something inside that bucket every single time. So what you can do is you can actually set this up. Let me move this over a little bit so we can see both. Is if you know that the object is always 10 centimeters to the left of this AprilTag, you can use -0.1 as an offset. Oops, I want to say -0.1. And then it's always 5 centimeters up. So -0.05 meters up. And now you notice that crosshair has changed. And it's always going to focus on that exact section. So you can get yourself a CAD model of the field and know exactly what point you want to focus on, so that rather than just looking at that QR code as where you want to place your object, you can use that 3D point of interest offset. So you can look, sorry, not QR code. You can look at that AprilTag and then find that offset, and that is what your target is now returning to. So this TX, TY, and TA is now returning you based off that interest point, not off the AprilTag, and that is where the real money of the Limelight AprilTag tracker comes in. Now, of course, you can send raw corners if you'd like to. You can send the JSON over network table, and then you can also set up your crosshair mode, so you can have individual crosshairs, just one crosshair, multiple crosshairs, whatever it is that you need. But I recommend that you don't really play with any of these personally. So I hope you found that helpful as an introduction to setting up AprilTags using the Limelight 3A. It is a phenomenal tool for being able to figure out where things are in physical space compared to your current robot's field of view. If you have any more questions about this, let me know in the comments down below. I'll try my best to answer it for you. I'm also going to be uploading a video about some basic code on how to use this in an FTC context. I'll have that in the description down below. Otherwise, I hope you found this helpful, and best of luck on your next robotics project.